Hello everyone, welcome to our easy class today. Today, we will talk about the hottest topic lately, cloud services. As we know, the internet is changing and the internet never stops changing. So, cloud services are the most popular topics recently. As the internet is changing, e-commerce is changing too. In this slide, we can see a big shift from traditional data centers to cloud data centers. Traditional data centers means the databases on your own servers located in your company or somewhere you know. And you have the access to that server physically. However, in cloud data centers, you don't know where your data is, which server they are stored. You have no idea about that. Just like in this graph, in traditional data center, every machine, every server has its own database and storage. Yeah, you can see every computer has its own database or storage. And this will make administrators crazy when managing all these complicated, scattered systems. However, in cloud-based data center, you only to connect to cloud interface here, and you manage data from that without knowing which server stores your data. Even you don't know where these servers are located. This makes life easier, right? Here, we can see the explosion of data on the internet. In 2007, there is a 5 exabytes per month, approximately 1.4 billion DVDs crossing the network. Until 2013, it is predicted that 56 exabytes traffic on the internet per month, about 12.8 billion DVDs crossing the network. Why do we have so much internet traffic growing so fast? One reason is multimedia traffic. For example, YouTube. The other important reason is the growth of connected devices. In 2007, only 1/10 of a device per person on Earth. In 2010, 5 devices per person on Earth. For example, smartphone, iPad, PC, laptop, and IPTV. In 2020, everyone will have 70 devices per person on Earth in prediction. As the number of devices go on, the data transmitted over internet grows respectively. Like the explosion of apps of all kinds of devices, we can see in the Apple Store, there are 350,000 apps in Apple Store. Let's see an example of Apple's iCloud. In old way, PC was at the center. Devices must synchronize. However, in a new way, cloud is at the center, accessible by any device, including the PC. So now, did you get a feel of cloud? It's like every PC, every phone, every device you have has its own storage. So we need to synchronize our data. But now we all put data in cloud. Cloud is at the center, and every device just access to the cloud to get the data. And that's it. It makes everyone's life easier. Thanks God. So we can see we use small devices or lightweight softwares and use the network as platform, seamless and securely connected with cloud data center. And then we can enjoy all kinds of cloud services, including media, government, game, or some financial services, health care, and so on. And in the future, video will dominate the information flow. We can see in 2013, 91% of all consumer internet traffic will be video. Therefore, we need a super large cloud data center. This is an example of data warehouse of Google. And we can take a look at a video explaining how Google brings cloud concept to the world. Enjoy the video. We'll come back later.
For computer geeks, the fun really began in 1977 in a Silicon Valley garage when two college dropouts started a company called Apple and launched a revolution, the personal computer revolution. The power of the desktop computer unleashed across millions of homes and offices around the world changed everything. But now, after more than a quarter of a century of insinuating itself into our lives, the PC has lost pretty well all of its original gee-whiz luster. Google has set its sights on creating another revolution by eliminating the need for desktop computers. It wants to put as much of that data as possible onto its own servers.
One of the things I think that's underappreciated is from the very earliest days, including at Stanford, they were great at minimizing the cost for putting together computer systems, and they've carried on that ability to deliver a huge amount of computing power at a relatively low cost.
From its beginnings, Google had made it a priority to manufacture as cheaply as possible all its servers and storage facilities to handle its fast search and logging of the internet. And as the internet has grown, so has the need for increased computing capacity.
Well, Google builds large data centers. We use personal computer components, and then we build a lot of specialized systems now to deal with the kind of scale that is required.
Scale is at the heart of Google. Not only does Google have access to almost limitless computer power, but perhaps of greater value, it has accumulated a massive collection of data. Data that can be used for testing at a scale unseen by most new computer engineers.
My office mate and I were just banting around some ideas, and we're talking about something that later turned into something close to Google Bookmarks. And, you know, we did a little bit of math and said, that'll be about, I don't know, 4 petabytes of data. That doesn't seem so bad. And that sentence, 4 petabytes of data, that doesn't seem so bad, is something that before I had been at Google for a month, I would have been shocked to hear those words coming out of my mouth.
That shocking 4 petabytes is the equivalent of 4 million gigabytes, numbers so staggeringly large that it is nearly impossible for mere mortals to fathom. As memory increases in capacity and decreases in price, Google is moving into something called cloud computing.
The whole idea behind cloud computing is to go ahead and get everything on their server where the professionals are managing it. The problem today is you've got all your stuff on your computer, you drop it, you break it, you delete it, it's a disaster. Why don't you put everything that's important somewhere else, keep it secure, keep it under your control. It's available to you on every demand, on every device, and everywhere you are.
The move to the cloud is ushering in a revolution in how we communicate, how we work, how we play, in fact, how we live.
People wonder, what's going to happen to information that is mine personally? It's my bank records, my health records, whatever it is, but I don't control it. It's sitting out there somewhere I have to just trust whoever has it to not do things with it I wouldn't want.
Is this move into the clouds opening a back door for governments and corporations to secretly access data about us? If everyone's digital data is moving into computer clouds, just where are these clouds? One of them has touched down in the foothills of the Blue Ridge Mountains in North Carolina. This was once the heartland of American furniture manufacturing. Then in the 1990s, cheap labor from overseas siphoned off the jobs, leaving behind a devastated economy and an awful lot of excess electricity. It just so happens that computer data centers are voracious users of electricity to run the servers and to cool vast quantities of water used for refrigeration. The town of Lenore had plenty of both, and so in late 2005, Google came calling, but it came cloaked in secrecy.
From Google's perspective, at least as I understood it, it was that the race to build these data centers is so intense, and the information, at least they see it, is so proprietary that they didn't want any of their competitors to get wind of what they were doing.
T.J. Rohr is a lawyer and a member of the Lenore City Council who was involved in the closed-door negotiations with Google.
They would reveal information to us that we couldn't reveal to anyone else. Google definitely had an attitude like, look, it's our way or the highway. These are the terms we're offering. Take them or leave them.
Desperate local and state officials were more than ready to reach a deal that would bring Google to this devastated county. They offered Google a 30-year tax break on property and equipment.
It was worth an estimated $165 million over a 30-year period.
From these digital warehouses estimated to cost $600 million apiece flows a stream of data. Here are the emails, the photographs, the music, the videos, the maps, and the searches that have made Google a data collecting powerhouse. Google does not divulge how many server farms it runs worldwide, but it is rumored that there are some 36 of them around the globe, all digitally connected and all firmly planted on land. But that might change. Google has filed a patent to build data centers out on the open sea. Powered by the latest technologies in harnessing wave energy, Google servers would sit out on barges. The expectation is that sea-bound servers would be much cheaper to run, and there certainly wouldn't be any real estate or property taxes to pay. A working model has yet to be built, but Google is a corporation that likes to move quickly when cutting-edge technology is involved.
Hi, we are back. After looking at the Google video, believe everyone knows how great the cloud is and how large the data center is, and it will be the high-tech trend in the future. Definitely, cloud will also change e-commerce. We continue to see what cloud services are. These are the current cloud services. We can sort of categorize these services into 3 forms. The first one is SaaS, stands for Software as a Service. The second one is PaaS, stands for Platform as a Service. The third one is IaaS, stands for Infrastructure as a Service. First, what is IaaS? IaaS provide computing and infrastructure, and the infrastructure stack include full OS access, firewalls, routers, and load balancing. A very good example is Amazon Web Services. We'll talk about Amazon more later. The next one is PaaS. PaaS provide a platform for system development and administration. The popular PaaS services include storage, database, and scalability. Examples are Google App Engine or AWS, Amazon Web Service S3, Microsoft Azure, Apple Store, or Android Market. The next one, and also the most popular, the most common one, is SaaS. SaaS provides online software for use. Examples are Google Docs, CRM, financial planning, human resources, word processing, Salesforce.com. Okay. Then, let's take a look at a very good video produced by Microsoft. And okay, now let's take a look at a video produced by Microsoft Azure Cloud Service. This video will explain very well about what we have talked about today regarding cloud services. Let's take a look at this video.
To meet ever-changing business needs, organizations need to invest time and budget to scale up their IT infrastructure, such as hardware, software, and services. However, with on-premises IT infrastructure, the scaling process can be slow, and organizations are frequently unable to achieve optimal utilization of the IT infrastructure. Cloud computing is a paradigm shift that provides computing over the Internet. A cloud computing service consists of highly optimized virtual data centers that provide various software, hardware, and information resources for use when needed. Organizations can simply connect to the cloud and use the available resources on a pay-per-use basis. This helps companies avoid capital expenditure on additional on-premises infrastructure resources and instantly scale up or scale down according to business requirements. You can deploy a cloud computing service by using 3 different models: a private cloud, a public cloud, or a hybrid cloud. A private cloud functions solely for one organization, on a private network, and is highly secure. A public cloud is owned by the cloud service provider and offers the highest level of efficiency and shared resources. A hybrid cloud is a combination of private and public deployment models. In a hybrid cloud, specific resources are run or used in a public cloud, and others are run or used on premises in a private cloud. This provides increased efficiency. Cloud computing consists of the following service models: Infrastructure as a Service, ES, Platform as a Service, PaaS, and Software as a Service, SaaS. By using the ES model, organizations get infrastructure components, such as computing power and storage capacity. Here, the organization has control over the entire IT infrastructure, including the hosting environment and their applications. However, the organization needs to allocate additional staff to maintain and manage the infrastructure and the application. Microsoft has proposed remote desktops and virtual machines to Microsoft Windows Azure as an ES offering. The PaaS model provides organizations with a platform or a runtime environment to create and deploy applications. Here, the organization is only responsible for the development, maintenance, and management of the applications. Microsoft provides the Windows Azure platform as a PaaS offering. The SaaS model provides organizations with ready-to-use applications that use a combination of cloud-based compute and storage services. Microsoft provides various online services, such as Microsoft Business Productivity Online Suite, BPOS, and Microsoft Dynamics CRM Online as a SaaS offering. To understand how cloud computing can help an organization extend its IT capabilities, consider Wide World Importers, a company that manufactures beauty products. Occasionally, the research department has to store and process a large amount of data. Consequently, the company is looking for a cost-effective compute and storage solution. Additionally, Wide World Importers has a group of scientists situated at different geographical locations. The geographical barrier affects research, requiring a better collaboration solution. In addition, the company is planning to develop a cost-effective data mining application to collect visitor data during its week-long worldwide annual beauty pageant. Cloud computing provides Wide World Importers with an efficient and cost-effective solution to their problems. Wide World Importers can subscribe for additional compute and storage services offered by Windows Azure on a pay-per-use basis to move all of its statistical data analysis and storage to Windows Azure. By doing so, they can invest more on research. Wide World Importers can use BPOS, Microsoft Live Meeting, and Microsoft SharePoint Online for efficient collaboration. For design, development, and testing of the data mining application, the company can use the Windows Azure platform to focus on software evaluation and reduce the time and cost required for preparation of the development and testing environment.
Okay, we are back. So after looking at the video produced by Microsoft, I believe everyone should have a better idea about what cloud services are, how we can use that in our business. And here comes the summary of today's class. Cloud services means large amount of data and put everything on remote data center and access the data from your lightweight devices. And there are three forms of cloud services. The first one is SaaS, Software as a Service. The second one is PaaS, Platform as a Service. The last one is IaaS, Infrastructure as a Service. So, in the next class, we will talk about how cloud influence e-commerce and what and how are those leading cloud companies in the world. So, see you next time. Bye.